All right, well, thank you very much for the opportunity to share and discuss some information regarding centralized versus decentralized. My name is Hyman. I'm the current president of Goss Engineering in Corona, California. So when we talk about central plants, what are we talking about? Well, we're talking about chillers, boilers, combined heat and power, thermal storage, different types of pumping systems, the distribution system, and the building interface. Now, there's all types of different chillers. There's centrifugal chillers, electric drive centrifugal chillers. There are absorption chillers. There are steam turbine-driven centrifugal chillers, and as well as a number of type of boilers. So we have steam boilers, we have hot water boilers, we have superheated steam, saturated steam, high temp hot water boilers. Combined heat and power is a simultaneous production of both heat and power from a single fuel source. It's very efficient thermodynamically. We can use 80%, even 90% of the fuel use, and it helps on reducing overall carbon emissions when the utility plant is considered. We also have thermal storage systems, which is like a battery, a thermal battery, which allows us to produce, for example, chill water at night, store it at night for use during the day. Very efficient, can save almost 20% on energy costs. We have different types of pumping systems to distribute either chill water or heating hot water, for example, or even steam out to our building systems. And then, of course, there's an interface, either a direct connection or a heat exchanger that will transfer our thermal heat, for example, to the building. For example, we might have a steam to hot water heat exchanger, which would transfer again that steam energy into the building hot water energy. So just for a moment, let's talk about, there's sort of a fractal nature of distributed systems or central systems, in that one person's central system might be another person's decentralized system. So it depends really what your, how much you're zoomed in or zoomed out. So for example, let's look at a plant, a chiller plant in a building. Now for that building, if you look at the building, well, that's the central plant for the building, right? Because you could have individual package units for various zones. So we have a central plant in the building. Now if we zoom out to the campus level, we wouldn't say that that building chiller plant is a central plant. We would consider it a distributed plant because we have our own central plant. And for example, let's say we had a cogen plant. So now is that central cogen plant, is that a central system? Well, again, it depends on your viewpoint. If we zoom out farther to the utility view, well, the utility will say that that's a distributed plant, right? Not a central plant. So it really depends on where you look at. And there's always going to be this tug of war, if you will, between centralized and decentralized systems. And so with both cases of too much in either case, so you can see that in some cases, for example, where we're too centralized, then the central office, for example, is too far removed from what's happening on the front lines, and they're not able to optimize or to respond quickly to changes out on the front line, right? Maybe there's too much bureaucracy. On the other hand, you could see a case where there's too much decentralization and everybody's going in different directions and we don't have a common goal or a common theme or a common standard. So as with everything in life, there's always pluses and minuses that we need to look at. So let's talk a little bit about some of the benefits and challenges of central systems versus decentralized systems. So one benefit, of course, is that you could have reduced emissions, because when we have all of our equipment in a central plant, it's going to be easier and less expensive to specify, for example, a low NOx boiler on that boiler and to pay more for that boilers in the central plant versus to do that for all of the individual boilers spread out through various buildings. Likewise, it's going to be less costly. It's going to be easier and less costly for administration costs. You can just picture, say I have, every building has its own boiler, and I have to keep track of the emissions of that boiler and do all the paperwork for all of those individual building boilers. That's going to be more difficult and time-consuming than if I just have to worry about a few boilers, 2, 3, or 4 boilers, for example, in the central plant. Likewise, you would typically imagine that you could have fewer personnel to manage a central plant versus if I have to have operators or engineers out at every building operating the system. And similarly, it's going to be easier and less costly to maintain equipment all located in one spot versus having to send people out to all the individual boilers. And you would think that a handful of boilers, 3 or 4 again boilers, are going to be easier to maintain versus a lot of distributed boilers throughout a campus. And similarly, if you look at risk, what is the risk of having boilers out in every single building versus having a few boilers in your central plant, and you could design your central plant with alarms, controls, make it a bunker, if you will. So it would seem like there's less liability with a central plant. And another benefit is now that space in the building that would have gone to a chiller plant or a boiler plant can now be used for assignable square footage. Continuing on with central plant benefits, typically we see that a central plant has a higher efficiency. We can spend more money. It's worth it to spend additional money at the central plant to make it more efficient. And we'll also have a number of equipment, and so it's easier to stage equipment to meet the load than it is in an individual building. Likewise, it's easier to provide backup. Think about having a boiler in every building. Now, if I want to have a backup, I need to put an additional boiler, so I'm having 2 times the amount of boilers that I would need. Versus a central plant, if I have 4 or 5 boilers, I can easily just add 1 more boiler to provide for my backup capacity. With central plants, you also have the opportunity to use a variety of energy sources, if you will, to develop a hybrid plant where you may be using electricity, you may be using fossil fuels, you may be even using solar power. And with respect to the fuel, you have now opportunities to use a variety of fuels. Maybe we want to use biofuel. Maybe we're using liquid fuel. Maybe we're using natural gas. Also with a central plant, it's much more easy to incorporate technologies such as thermal storage and combined heat and power. You can see in this picture here that there's this large thermal storage tank. It would be challenging to try to find and put a tank at each building, for example. Of course, everything has its pluses and minuses, and central plants are no exception. There are challenges with everything. Typically, with the central plants, you're going to have more specialized engineering and construction versus, say, putting a package unit in for a zone. The cost to construct is probably going to be more costly. It will probably require an investment into a central plant with a payback over time. And one of the most critical and difficult challenges with a distribution system, with a central plant system, is putting in a distribution system. So you can imagine if you're in a downtown area, it's going to be a lot of challenges with street disruptions and closing off traffic. Also, there's a lot of places where the street is already full of utilities, and it's going to be a challenge to locate your new distribution system among those existing utilities. Maybe you're going to have to do piping reroutes, right? So that can be a challenge. And even if you don't have, you're not in the street with a lot of utilities and traffic challenges, you're going across the campuses where you still have hardscape to deal with, landscape to deal with, underground utilities, and the infamous unforeseen utilities that can be in your way as you're trying to put in this distribution system. And typically the distribution system is really a major hurdle to get over as far as cost. if you look at the equipment itself, it's not exactly correct. Let's just say it's a wash, the amount of boilers you can put in the buildings versus a central plant. But with a central plant, you have the cost of a distribution system, which can be significant depending how far and spread out your buildings are. Also with central plant equipment, we're often dealing with more sophisticated, higher quality, industrial quality systems that might require specialized maintenance versus your local, commercial quality type of equipment. And of course, you're going to need to find an area and a place to put your central plant, and that's often a challenge where you have constrained spaces and not open space to build a central plant. And I show there in the bullet point, preferably you'd like to have your central plant at the centroid of the loads, in the center of where the loads, that will minimize your distribution costs. However, sometimes we found that people would like to have their central plant sort of out of sight, out of mind, and at the farthest location away from the campus for aesthetics reasons. And with central plants, you have a longer time horizon, so you need to consider what your future loads would be, how you can expand your plant. Are you putting in larger equipment now, paying for larger equipment now for the future? How about decentralized? What are some of the decentralized benefits? Well, I think one thing is that it tends to be more robust, less prone to failure. So you can imagine that if you have chillers in every building, and one chiller fails, then you've only lost that building. Now, how about if there's some catastrophic occurrence at your central plant, it gets hit by a meteor, for example, or something more realistic like the power feed goes out. Then you've lost your whole central plant, and now you've lost cooling to all your buildings. So there's less risk because if one goes out, one cell goes out, it doesn't affect the whole system. And typically it's going to be less costly to repair. Just go in and replace that one package unit, replace that one boiler, replace that one AC unit, for example. And in converse to the central plant with a decentralized system, you won't need a distribution system, so you can save yourself those headaches. What about challenges? Well, there's also challenges with decentralized systems, like anything. And it's sort of the converse of the advantages of the central plant, if you will. That it's going to be more difficult and costly to administrate the costs. It's going to require more maintenance personnel to go out and take care of a lot of individual package units everywhere. Right? It's also going to take up some of the building space. Presumably it would not be as efficient as a central plant, although that's not always the case, because you could, for example, get a highly efficient condensing boiler, which would be the same efficiency as a central plant boiler. But in general, it's going to be more challenging, as I discussed, and more costly to provide equipment backup generally. And it's going to be more challenging to incorporate energy-saving technology such as CHP and thermal energy storage. So what are the factors that you need to consider if you're thinking about, well, should I have a central system or a decentralized system? And here's just some of the factors to consider, certainly not all of them. One is, what are the existing systems, right? So one issue would be, are you dealing with a greenfield, a brand new campus? Well, it'll be a lot easier, of course, to plan for a central plant and put in your distribution systems versus if you have an existing campus. And with existing systems, what type of chillers do I have? What type of boilers do I have? How easy will it be to use a central plant versus distributed? What are our loads? What is a peak load? What is the magnitude and duration and nature of our loads? Of course, the larger the loads are, the more cost-effective it will be to serve it with a central plant. You can imagine if the loads are small and only happen for a few hours a year, it probably wouldn't be worthwhile investing millions of dollars in a central plant that's only going to be needed for a few hours a year, right? Compared to, say, another facility that has 24-hour, 7 days a week loads with high base loads, then that would be a different case. What are the plans for the future loads? Are we, is a facility growing? Is a campus growing? Are we going to want to expand loads? And we might find that it'll be a lot easier to expand our central plant, perhaps, than to put individual systems in buildings. What are the utility costs? That's what are the rates, right? Those are going to be important. How much are we spending on utilities? That'll give us an idea of what we can save and whether it's going to give us an attractive payback. What are the difference between, say, on-peak and off-peak, which could lead us to showing that, for example, thermal storage had an attractive rate of return. Load density. How easy or difficult will it be to put in a distribution system or distribute our hot water or chill water, for example, to the loads? So with denser loads, it's going to be easier to serve. The more sparse loads are, the more spread out they are, the more expensive it will be to put in that distribution system, right? And how easy or difficult will it be? Some places are virtually impossible to put an underground system, and sometimes we try to look at above ground systems or going through buildings. Other areas, it's wide open spaces. Go ahead, no problem at all. So these are just some ideas to think about, to let you consider about. Additionally, do we have space for central plant? In some of our projects, we want a central plant, but there's just no room. All of the land is taken up with it. In that case, sometimes we've looked at distributed plants where we actually have many central plants, if you will, in various buildings, and we connect them to a distribution system. Right? Is there other ways to, as I mentioned, to route our piping than to have to go direct buried? How much will it cost to construct, right? How much will it cost then to operate and maintain? What are our energy costs going to be? Will we operate the plant, or would we, as some do, outsource the operation of the plant to a third party? And then we want to look at the life cycle costs and economics, right, the engineering economics, to see if our investment's worth it. There's always scarce resources. There's always competing needs for resources, if you will, for money, if you will. So we always have to look at the best use of our money, and there's different metrics for doing that. Rate of return, for example, net present value of cost, the lowest cost or the highest net present value of savings, uniform annual equivalent cost, a number of metrics that we use, but we want to look and see and allocate our money to make sure that it's worthwhile. And with that, I would conclude, and I'd be happy to answer any questions.